Hi, welcome to our new series on calculus. As a first video, we will introduce to the concept of limit. Limit is the fundamental concept on which the whole calculus is built. However, it can be very difficult to get our heads around what is a limit and why do we go through so many complex methods to calculate a limit. In this next series of videos, we will try to build the concept of limit by going through examples starting from the trivial and introducing complexities one step at a time. Hopefully, by the end of the series, you should be able to calculate a limit. You should be able to figure out which method to apply and apply that and be able to calculate the limit and be able to explain what a limit is. Let's start with a simple trivial example of a limit calculation. In a limit problem, you are generally given some function f of x and a value a, and you're asked to find the value of this function when x is equal to a, which is nothing but f of a. But instead of writing like this, we write limit x tends to a f of x for a reason, because in some cases, in fact in many cases where we calculate limit, f of a may not be defined, right? And then we use various techniques to find out approximately what is the value of f of a. So let's take an example. So in this example, f of x is this function. So like I said, all we want to know is what happens to this function, what is the value of this function at x equal to 2. It can be found simply by substituting 2 in place of x. When we substitute 2 in place of x, we get 4. 2 square is 4 plus 5 divided by 4 minus 1, which is equal to 9. So in this case, it is a very straightforward case of substitution. Let us see one more example. In this example, we have a larger numerator and a smaller denominator. And in this case, x is tending to 0 instead of x tending to 2 in the earlier one. Here again, if we just simply substitute, we should get our limit value. Substituting 0 for x in this expression, we get 0 cube minus 3 into 0 plus 1 divided by 0 minus 4, which is nothing but 1 divided by minus 4, which is equal to minus 1 by 4. So minus 1 by 4 is the limit of this expression when x tends to 0. The expressions typically will be algebraic, or it can also be trigonometric. Let us check one trigonometric expression where simple substitution will give you the limit. In this example, we have a trigonometric expression. As x tends to pi by 2, we want to find out what is the value of 2 sin x minus cos x plus cot x. Like all other trivial examples, in this example as well, if we substitute pi by 2 for x, we will be able to find the limit. Substituting pi by 2 in place of x, we get 2 sin pi by 2 minus cos pi by 2 plus cot pi by 2. We know from trigonometry, sin pi by 2 is 1, so this gives 2 into 1, minus cos pi by 2 is 0, and plus cot pi by 2 is again 0. So we get the limit as 2. So in many expressions, in fact most expressions, we can find limit by just substituting. Mentally just substitute the x value at which you want to find the limit in place of x and calculate the expression, you might get the limit. But in many cases, the limit is not as straightforward as substitution. Let us see one example. In this example, we want to find the limit of this expression as x tends to minus 2. Like in our earlier approach, let us see what happens if we substitute minus 2 in place of x. When we substitute minus 2 in place of x, this expression becomes minus 2 cube plus 3 into minus 2 square plus 2 into minus 2 divided by minus 2 whole square minus of minus 2 minus 6. Let's evaluate this expression and see what happens. So the first one is minus 8. This is plus 3 into 4, and this is minus 4 whole divided by 4. This is plus 2, and this is minus 6, which gives us this whole thing. When you do the arithmetics, gives you 0 divided by 0. It's an indeterminate value. So how do we then find out what is the limit of this function as x tends to -2? This brings us to the another method, the non-trivial method of finding limit, where we can simplify the expression using factorization. We simplify the expression and then apply the limits to find the value. We shall see more examples of this and learn this technique in the next video. In the meanwhile, practice a few problems of finding limits by substitution that is given in the comments. Thank you. Keep watching MathSmart.